As part of your homework, you were supposed to read all of those packets and look at the example images for learning how to do dimensioning. And there are so many rules about dimensioning for us to learn, but I'm going to try to break it down so that we have the most basic and simple, the most important concepts ready to go. So what you're going to need to do is get out this handout. We're going to be learning a few rules together and drawing them together, okay? So with this one, we're not actually going to be writing physical dimensions, like the actual numbers, but we're going to learn about the different dimension lines, the extension lines, and where we place the different bits of information. So first of all, we have 4 different exercises, and I am going to split my paper down, which is kind of a red line. Now with this note taking, feel free to use colored pencils, just because the grid just kind of hides pencil. I'm using a pen, but you know, be careful because the other side of this handout has another side that you don't want it to bleed through, otherwise it's going to get more difficult. So here we go. So I have it sectioned off, so I have my 4 different exercises, okay? And we're going to start with the most basic. We have exercise 1, okay? Looking at exercise 1, we have a top, a front, and a right side view. Now, since we have 3 views, every view needs a dimension. So that's one rule. Every view needs at least 1 dimension. Okay, so we're going to be starting off, since it's a basic rectangle, what 3 dimensions do we need? We need the height, the width, and the depth. Now the height can be indicated either on the front view or the side view. Both of these views show the height dimension. So I'm going to put it on my front view just because I'm just making a decision. So I'm going to create my extension lines, and notice that there's like a 1/16 or even just a 32nd of an inch gap. Your extension lines don't touch the actual object. And in between those 2 lines, we're going to have our dimension line. And it has those skinny arrows. You should not have wide flaring arrows, but they should be nice and thin. So it's essentially pulling your pencil back along the same line as sweeping out. And then right here you would have your number in that gap, not beside, not above. It needs to be in that gap. So I'm going to put the letter H for height. Okay, just so you know that would be a height dimension. Okay, so we need our total height. We have it. We need our total width. Width is from left to right, and that can either go on the front or the top view. Because I only need 3 dimensions, height, width, and depth, okay, this view already has a dimension. So the next one, the width, I'm going to put on the top view. Okay, and once you get a hang of how to do this, you know, if you learn the simple tricks, they all become pretty easy. Okay, width. And then the depth is the dimension from the front to the back of the object. That could either be done on the top view or the side view. And the side view is the only one missing a dimension. Okay. Depth. Okay. Every view needs a dimension. Every drawing needs a total height, width, and depth. Okay, this one's very easy to get that on, but the next several, you'll see that they have multiple pieces. Do not make the person trying to interpret your drawing add it up themselves. Okay, so let's scoot over to exercise number 2, because number 1, that's all we actually need. So for our total, we have our front view and our top view. Our total height has to go on the front view because there is no side view to use. Okay. Also, I need to teach you the rule of one less. Okay, yes, I'm writing these rules down. I'm using this as an example and as a note page. Okay, so the thing is, we are going to be needing the total height, but you can see that there's variation in this shape. It's no longer just a rectangle. So when we're trying to decide how many dimensions we need in order to fully dimension it, but not over dimension it, we're going to use the rule of run less. Over dimensioning means you put too many dimensions on and it's over constrained and it just looks busy. The entire purpose of dimensioning is to clearly explain yourself. Okay, so I'm looking at height lines. So these would be my horizontal lines. This would be 1, 2, and 3. So there's 3 elevations. The rule of one less means that I take one less of those different elevations, which means I would need a total of 2 dimensions. Okay. Okay, with that, we're going to use largest is furthest out. Okay. You are not allowed to cross dimension lines. You can cross extension lines, but the dimension lines, the ones with the arrows and the number, think of those as kind of like electric fences, and you get zapped every time you cross through that boundary. So I need, according to what we just counted, 2 dimensions. So I'm going to put the first dimension right here. That's a height. Okay, and a lot of people will be tempted to go from here to here as the next dimension, but don't forget we have to have the total, so the overall. The reason for that is when you're doing the machining or when your machinist is getting ready to make this part, they need to know what size of material to start out with, okay? It's going to be slightly bigger than what you've asked the finished size to be, but to get a piece of stock material quickly, having the total height and not making them add it up themselves moves things along faster. Plus, it's the most efficient way to do it. So we have 2 heights. Okay, because we're also missing our right view, the other dimension that we need is depth. Okay, because remember, the right view can have either height or depth dimensions on it. So that means the depth dimension is going to be on the top view. So I'm going to bring that out. Okay, notice I am not freehanding that. Always use your straight edge. And then the width dimensions. Again, the rule of one less. So width, we're counting 1, 2, 3. 3 lines, which means I need 2 dimensions. Now, here's another rule. Do not dimension just to a simple line. You're going to be very tempted because it looks nice and easy. These lines are easy to get to dimension up here. But looking at just that top view, that doesn't tell the machinist anything. You're going to dimension on the view that shows shape. Okay, that means the change in the contour. What those dimensions are saying is not from this line to this line, but from here to where we have a step down. Okay, so the first width dimension I'm going to place here, and then the second width dimension I'm going to bring up from there. Okay, Notice that I crossed the extension lines. You can cross extension lines, but you cannot cross through the dimension lines. Okay, another rule is about to happen. It's called all in or all out. Okay. The reason that exists is because if you just randomly put a dimension here and then arrows, you have to fit either all of your information with your arrows and your number inside, in between your two extension lines, or all of it goes outside. Otherwise, it's confusing. Otherwise, you're going to be wondering, what is this arrow even pointing to? So you don't have to have the entire drawing with everything outside of the object if you can't fit it all in on one. You can do a combination of the two. So this example is all in, and that example is all out. Okay, the arrows with the dimension are outside of the extension lines. Okay, again, just having the arrows in between and then a random number somewhere outside, that's confusing. So you want to make sure that you have it all in or all out. Another thing I can anticipate some of you asking, well, can't we put the total width up here? Yes, absolutely. As long as the one that's a dimension that's showing a change in shape is on the view that shows shape. Numbers 3 and 4 coming soon.